Okay, so in today's video, we want to look at how do we go about doing what is called an optimization problem. So in general, an optimization problem is one where you're trying to optimize, so generally either maximize or minimize something. And as we've seen previously, as long as the function is differentiable, then maximizing or minimizing a function is basically the idea of coming up with where does the derivative equal 0. But in most optimization problems, your first task is to actually come up with the function that you want to either maximize or minimize. So we're going to look at this example here. The question is, what point on the line, so right here, on the function y equals 1 minus x squared, so that's a parabola, is closest to the point 1, 1. All right, so in order to start this, what I'd strongly urge is, when possible, start with a basic sketch, or even, go into your graphing calculator or Desmos and start with a graph of what you're thinking about here. So in this situation, we have something like this. Okay, so let's say that this is 1, and this is 1 here. And so we have this function here that is going to look like this. All right, and we're interested in what is the closest point to that closest point on the parabola to this. Okay, now before we go any further, let's just kind of intuitively think through what it should be. So obviously it should be somewhere in between x equals 1 and y equals 1, right? And moreover, if we were to zoom in on this, so I'm just going to do that real quickly. If I had something like this and here, and I zoomed in, if we drew a line from the curve to the point, what would we expect to be true of this line and that curve? Well, if it's truly the shortest distance, we would expect that this would be a right angle. In other words, and the language we use there is that it would be orthogonal to it. You can think of that as being perpendicular. So the way that we can test that later on is we can draw a tangent line here. So let's say that we drew this tangent line. And if the line containing those 2 points is perpendicular to the tangent line, then we can be fairly confident that that would be the shortest distance. Okay, so as I mentioned, one of the most important things that we'll do is come up with the function that we want to, in this case, we want to minimize it because we're looking for the closest point. Okay, so what is that function? Well, remember, in essence, we're wanting to minimize this distance here, right? And remember that the formula for distance basically comes from, and I want to show you this, it comes from the Pythagorean theorem. If you have 2 points and you draw that right triangle, right, then this is the change in x and this is the change in y, and this we could call the distance. And so what we know is that the distance squared would equal the change in x squared plus the change in y squared. So therefore the distance itself would equal, and this is the formula that we generally use, the square root of the difference in the x's squared plus the difference in the y's squared. Okay, so this is the function, and I'm going to go ahead and write it as a function of x. Okay, now you might think, well, wait, isn't it a function of both x and y? And that's true in its current form, but we will be able to get it into a function of just x. Okay, So this is the function that we want to minimize. Okay, and so what we'll do here, we know our 2 points here. We'll say that point number 1 is the point 1 comma 1. So that's this point here. And then point number 2 is whatever point is on the actual curve. So we know that the x, when we're on the curve, any point on this curve here is x comma 1 minus x squared, because this is the function. This tells you that if you want to get a y out, you plug in an x, and that's how you come up with it. So this is what we're going to do. So if we look at this here, we're going to have then the derivative, the function d of x is going to equal the square root of, so we'll have x minus 1, so that's x2 minus x1 squared, plus, and then 1 minus x squared minus 1 squared. Now, if I simplify this, I get, so I'm going to go ahead and square that out. I get x squared minus 2x plus 1. And notice here that the 1's cancel, and so I'm just left with x to the 4th when I square that. Okay. This is the function right here that I want to optimize, or in this case, minimize. And that's often the most challenging part of these problems, is coming up with that function. Okay, so I want to minimize this. And as we've already noted, when we want to minimize something, we're going to take the derivative of this one. So what we'll do is the derivative of this, so I'm going to write it like this: d prime of x is equal to, now this is a, something raised to the 1/2, so we're going to say that's 1/2, and then it's going to be x squared minus 2x plus 1 plus x to the 4th raised to the negative 1/2. Now we're going to apply the chain rule, and the derivative of what's inside is 2x minus 2 plus 4x cubed. Now, we're just going to simplify this a little bit, and notice that I can factor out a 2 out of here, so what I'm going to get is a 2 times x minus 1 plus 2x cubed over 2, that comes from right here, right? And I factored out a 2 out of here, so factor out a 2. And then we get the square root of x squared minus 2x plus 1 plus x to the 4th. Okay, so this is my derivative. And remember, the key issue here is I want to set this equal to 0. Okay? So, and you can think about this. So this is the distance function. And notice that when x gets very large, this number is going to get very large, right? So as x gets very large, and in fact, if x gets large in either the positive or negative direction, this is going to become very large. So the issue here is, where is it going to be the minimum? So you can imagine that this function here is going to be minimized somewhere along, and if you think back to this, we know it's going to be somewhere in here in this region between x equals 0 and 1 and y equals 0 and 1. Okay. Now, in general, a fraction like this is going to equal 0 when the numerator is 0. So we're just going to mess with the numerator, and so we can say that we want to know, when does x minus 1 plus 2x cubed equals 0. Now, at this point, because this is a cubic function here, we're not going to be able to solve that by hand, and so we would use, something like our graphing calculator or maybe Desmos and solve it. And when I do that, I get that x is approximately 0.5898. okay? And then if I plug that in, y would be approximately 0.6521. So this is my point that, at least at the moment, we feel like is the point on the curve that is closest to the 0.11. Now, in order to kind of verify that, let's go to Desmos and do some graphs. Okay, so first what I've got here is this is the actual function in green, 1 minus x squared, and there's the 0.11. And so what we want to know is where along here is this the closest. Now, notice if I type in this point right there, it does appear if that there aren't any points closer than this, right? Right there, that's the point that we found. And moreover, if I type in the line that is tangent at that point and the line that is through those 2 points, I do get something that appears to be a right angle, okay? And you could verify that by looking at these 2 slopes. So there's one slope and there's the other slope, and they should be negative reciprocals. And I'll leave that to you to verify, but that is going to be the case. Now, we've done a little rounding, so they might be a slight bit off, but it'll be close. So that's how we can minimize that distance. And again, the key is to come up with a function that you want to either minimize or maximize.